In this video, we'll continue our look at inequalities. Specifically, we'll look at how to graph an inequality. Example 2. State each mathematical relationship in words and then graph it. X less than -1. We read that as x is less than -1. Now, there's a difference between this expression and the expressions we were working with in the previous video. In the previous video, we had two numbers, -2, +4. So we said -2 is less than +4. Or we had 10 and 4, and we would say that 10 is greater than 4. But here we have a variable, and that's going to change things a little bit, because the variable can represent any number. Well, it can represent any number that satisfies this inequality. What does that mean? X could be any number that is less than -1. How many such numbers are there? There are an infinite number of possibilities. -2, -20, -3000, -1.5 even is to the left of -1 on the number line, and so it is less than -1. Now, since we have an infinite number of possibilities, we need a special way of representing those visually so that we can easily see what the different solutions, valid solutions to this inequality are. So we start with our number line. We put a -1 there. Now up in the top left-hand corner, I have an important note. Less than and greater than do not include the endpoint. What do I mean by that? -1 is not less than -1. So -1 is not included in the possible solutions of the inequality x is less than -1. So to represent that on our graph, we're going to use an open circle at -1, which means we don't include -1 in the possible solutions to this inequality. And then we're going to shade in the direction of the inequality. Since it's pointing to the left, we're going to shade to the left, and what we have here is a graphical representation of all of the solutions to the inequality x is less than -1. B, x is greater than, notice the line underneath the greater than, that means could be equal to as well. And we read that as x is greater than or equal to -2. As long as it's greater than or equal to, you can't be both, you can't be equal to something and greater than, but you could be either greater than or equal to. And as long as either of those is true, then you are the number is part of the solution to x is greater than or equal to -2. How do we represent that on a graph? We draw our number line. We have our -2. Now, up in the top right-hand corner, another note. Less than or equal to and greater than or equal to do include the endpoint. What do I mean by that? -2 is greater than or equal to -2. It's one of the infinite solutions to this inequality. We do include -2, and the way we represent that on the graph is by using a closed circle at -2. Then we shade in the direction of the inequality. Again, that's to the right. And so that is a graphical representation of all of the possible solutions to the inequality x is greater than or equal to -2. Now, in C, we have something that's a little bit different. It says -3 is less than x. Well, it's harder for our minds to really understand that. It's easier if we know x can be any number less than -1. X can be any number greater than or equal to -2. So what we want to do first with this is, instead of reading it as -3 is less than x, we're going to read it from right to left. And that would be read as x is greater than -3, from which point we can rewrite the inequality itself as x is greater than -3, the same way we read it from right to left, and we're ready then to begin to graph that inequality. We set up our number line, we have our -3. Since it is strictly greater than -3 to be part of the solution, you cannot include -3, and we use an open circle at -3. We shade in the direction of the inequality, which is to the right, and so that is the graph of the solutions to x is greater than -3. In D, x is less than or equal to -1/2. We set up our number line, our -1/2. Since -1/2 can be included in the possible solutions, there is an equal sign under the less than. We have a closed circle at -1/2, and we shade in the direction of the inequality, which is to the left, and that is the graph of x is less than or equal to -1/2. All right, it's time for you to try some. So here are 4 graphs. Pause the video, state each mathematical relationship in words. You can just say it out loud, and then graph it on the number line, restart the video, and check to see if you're understanding what we're doing here. Okay, A, x is greater than 5. Because there's no equal sign, we don't include 5 itself in the possible solutions, and so we want an open circle at 5. We shade in the direction of the inequality, which is to the right, and so that is the graph of the solutions to x is greater than 5. X is less than or equal to -2. This time we do have the equal sign underneath the less than, and so we're going to use a closed circle at -2 to indicate that -2 is included in the solutions. Then we shade in the direction of the inequality, which is to the left. In letter C, we have one of those confusing examples where the variable is on the right. So what do? We read from right to left, x is less than 3. We rewrite it the way that we read it, and then we're ready to begin to graph. Here we do not include 3, so we have an open circle at 3. Then we shade in the direction of the inequality, which is to the left, and that is the graph of x is less than 3. X is greater than or equal to -3/2. We do have the equal sign, so we are going to use a closed circle at -3/2, shade in the direction of the inequality, and that is the graph of x is greater than or equal to -3/2. All right, so here are some more examples for you to work through. Feel free to pause the video, work through them on your own, and then start the video back up again and check to make sure that you got them correct. Okay, number 25, x is greater than 7. We have an open circle at 7. We don't include 7 in our solutions. Shade in the direction of the inequality. X is greater than or equal to -6. Here we do include -6, so we have a closed circle at -6. Shade in the direction of the inequality. 29. X is less than -1/4. We don't include -1/4, so we have an open circle at -1/4. We shade in the direction of the inequality. That is the graph of x is less than -1/4. X is less than or equal to -5.3. This time we do have the equal sign, and so we include -5.3. We place a closed circle at -5.3, shade in the direction of the inequality, and that is the graph of x is less than -5.3. 25 less than x, remember this kind, we read it from right to left. X is greater than 25, we rewrite it the way that we read it, and we start with an open circle at 25, shading in the direction of the inequality. All right, one last thing that we need to be able to do with graphs is to work backwards. That is, to go from the graph to the statement of the inequality. And so we're going to look at two things, well, three things. We're going to look at the number, where the endpoint is. We're going to look to see whether there is an open circle or a closed circle there. And then we're going to look for the direction of the shading. So in the case of number 35, we have negative 2/3, and there is a closed circle there shaded to the right, and so we say x is greater than or equal to negative 2/3. Why don't you try some of these? You can pause the video, try them, turn the video back on, or restart the video and see if you're getting these correct. Okay, number 36. Note the open circle at negative 4.5 shaded to the right. So we're going to say x is greater than negative 4.5. Number 37, an open circle. So we're going to say that x is less than negative 20. Number 38, we have a closed circle at 5/2 and shaded to the left. So we would say x is less than or equal to 5/2. Number 39, we have a closed circle at 3.7 shaded to the left, and so we read that as x is less than or equal to 3.7. Finally, number 40, we have an open circle at negative 10 shaded to the right, so we would say x is greater than negative 10. And that's going to do it for our section on graphing inequalities in one variable.